Today's coal-fired power plants emit massive quantities of carbon dioxide, a greenhouse gas which is arguably a contributor to global warming. With the push to go green and to use clean energy resources, the future of coal is bleak. Limited by our current technology, renewable resources alone will not be able to produce enough energy to sustain the country's growing demand. There is a need to develop technology to reduce carbon dioxide emissions so coal can remain a viable resource in the future. Post-combustion carbon capture technology is being studied at the University of Kentucky's Center for Applied Energy Research in Lexington.
Well, it's a scrubbing process, and many people are familiar with the term scrubbing. It's used a lot in power plants, and we use scrubbing technology for other pollutants like sulfur dioxide. It can be like the rotten egg smell and gas from the sulfur. What we do with scrubbing is we take a liquid, we spray massive amounts into it to a combustion gas. When we burn coal, we have a solid, we add air, forms carbon dioxide, and we have nitrogen from the air combining to make the flue gas. There's a little bit of oxygen in there also. So our goal is really to take that percent of CO2 in that flue gas, we call it, down from 21% all the way up to 100%. Okay, and we have to do that because to do something with the carbon dioxide, we have to be able to transport it. Okay, if we've got all the nitrogen and all the other components from the air in there, it makes it very difficult to put it in a pipeline. You have to compress it, and it turns out all the power to compress it would take up all the power you generate. So what we do is we take a portion of that gas, which is the CO2, compress that, and CO2 has the property of turning into a liquid when you compress it, so that makes it very compact. You can pump it, put it in a pipeline, and transport it to some geologic formation that will probably be off-site from the power plant. Okay. So the scrubbing, back to the scrubbing part, we spray the flue gas with a liquid, some chemical-based compound. The CO2 is absorbed from the gas phase into the liquid phase. Okay, so that gets it out of the gas. We can then vent that scrub gas out the stack, which is lower in CO2. Now we have to do something with that liquid. We just can't throw away that liquid. It's very expensive. So we have to regenerate that liquid. So we take that liquid, and I forgot to mention this is all cooled down. So it's a very cold, not a cold process, but it's about 30 degrees centigrade, nearly room temperature or hot room temperature. Take that liquid, put it into another vessel called a regenerator. Then we heat the solvent back up again, okay, and that makes the CO2 want to jump out of solution. And much like if you take a 2-liter bottle of Coca-Cola, put it in your car on a hot summer day, and you open it up, the CO2 wants to come out of solution. That's what we do with that regenerator. We essentially boil off the CO2 that exits the regenerator, and now it's a pure gas. And then we can take that pure gas, compress it, and turn it into a liquid and transport it, as I mentioned before. Then we take that regenerated solvent and recirculate it back to reuse it again. So it's just a cyclical process. So we don't use up, theoretically don't use up any of that solvent, we just recycle it. Well, the technology I just described, the scrubbing and regeneration technology, is actually used to scrub CO2, but not from flue gas from coal-fired power plants. It's used in petrochemical type plants, also to purify natural gas. When natural gas comes out of the ground, it has some CO2 in it, and we're able to scrub the CO2 from that and regenerate the solvent. So that technology is in place, but it's not been put in the scale that would be needed in the power industry. Everything's a large scale with power generation. Well, it would generate some chaos probably. Anytime these environmental technologies are put out, if rules are put out and implemented, and technologies out in the field don't work properly, there's generally a lot of money spent, a lot of wheel spinning going on in getting these technologies up to speed. But a lot of times that really improves the technology once you get out in the field. So it may sort of force a lot of technologies onto companies, and it will probably lead to a lot of innovation, a lot of improvements. We saw that many years ago when we were implementing sulfur dioxide rules, that we had a lot of scrubbing technologies that power companies didn't know how to operate. They're not chemical companies. They know about generating power, so they've sort of been forced to become a chemical company over time. But they learn very well, and then the experience out in the field makes improvements to the technologies.
Even though carbon capture research is a promising solution to the carbon dioxide issue, this alone will not be enough. In Dr. Jim Nethery's own words, if we want to decrease carbon dioxide due to power plants, the whole world has to do it.